So in number 5, as we move on in our 4-2 notes, we got to think about how these lines of reflection are going to look. So if we grab a color, our line of reflection for problem 5 has to be y equals x. And so we can go to the back of our page and like, what was that y equals x line looking like? Oh yeah, 0, 0, 1, 1. It was that perfectly diagonal line. And so I'm going to take my ruler, and this is going to get a little bit more challenging. Not only do we have to graph these lines that may or may not be familiar with to us, we got to get familiar with them. Then we got to think about, well, how does this reflecting over, how does this act? How does this act when we reflect over? Because it's not a horizontal or a vertical line. So I think our idea of how we go at it needs to be a little bit different. I'm typically looking at trying to get the point closest across the line of reflection, and I look at it like a diagonal. And I just sort of like dot it in. I'm going towards the line of reflection at a 90-degree angle. You doing all right, Makisa? You don't seem to be putting anything on your paper. Join me. Does anybody need me to slow down, or are we all right?
We all right so far.
Okay, get your line on there.
What's that other line right there?
This is me just trying to get to where B prime's going to sit. Let me drop it there.
B.
Anaya.
I was doing it wrong.
Okay.
I was on that.
Better now?
Oh, no, I see how you're doing it.
So now, yep, and I'm hearing Jemiah's like, now I see how you're doing it. So then I think, all right, I got B landed here. How is D related to B? It's diagonal across 2 blocks. Yeah. So I think, this is the way I think about these things, is like, how many blocks am I going across? So I started by thinking about B being, got to take B, same distance. Now C is going to be a little bit different, but I kind of look at it like I'm going across blocks. Where's C going to land? I think it's going to go right there. And then I know this is a square, and once I have those 3, real easy for me to see where this last one goes. This must be where the A prime lands. I don't know if I'd say it's easy, but... Now, the one thing that I noticed is that when we went across the line, and I'm just looking back in that core concepts, when I go across y equals x, there is a rule. Dominique, this was what you had been interested in. What happens is your y and x values switch places. Your y and x values switch places. So with our y equals x line, we have a rule. Now, we also have a rule with our y equals negative x line. So we'll get that on there in just a second, but I'd like to present the rule to you because this exists in our notes. And this says we not only switch the coordinates, we not only switch the coordinates, but we take the opposite of it. So let's get this y equals negative x line on there. Y equals negative x is the diagonal line that goes through the opposite way we were. Now this little ABCD figure is kind of small. Don't wait for me. Start your reflection over the line once you have y equals negative x on there. Right now I want you to look at reflecting this over this line. This one's dinky.
Dinky?
Dinky.
It's not exactly on the point.
And it's not exactly on the point. I think B prime falls right here, doesn't it?
Yeah.
Now this one's kind of funky. I think this one's landing right here. And that's going to put C. Ooh, that might be C. 1.5. Oh, no, D's right here. Here's my D. This is my C. So once I got over there, I realized I wasn't quite right, but I made some changes to my letter. Honestly, this one, I probably would have had better luck with this one if I would have named the points A, B, C, D, and then done the actual transformation. So that would look like me going, A is 2, 0, because my grid, I'm realizing my grid goes by 2. B is sitting at 5, 3. C is sitting at 1 and 5. And D is sitting at 1 and 4. Now, according to the rule about transforming, to get to my image, that's going to be this one here, I need to flip the values and take their opposites. My A started at 2, 0. It's going to be flipped and opposite. My B started at 5, 3. Over that line, it turns into -3, -5. My C started at 1, 5. When I go over that line, it turns into -5, -1. My D started at 1, 4, -4, -1. And now as I look back, I did put my points in the right spot. But I think this graph was a little bit challenging. That's why I wanted to go here. You need to have the ability to do both. Do it on points if you're not in a grid. Do it in a grid.
So basically you just flip everything and make it negative.
That's the rule for y equals -x. And then those rules, again, are in your notes packet above where these extra practice problems started. That's where I snagged that information from. As soon as we change to an x equals like some other number, x equals -1 or y equals 5, we don't have any of those specific rules. You do the flip. We could come up with them, but that's not a requirement right now with our reflections. We could. Now,
So you only do the flipping thing if it's negative fix?
nope, I flipped them both, but if you just, what's the opposite of 0? It's just 0. So on both of these, it was the opposite, flip and opposite, but 0 doesn't have an opposite. That's the reason why that one didn't change. Look at the other one. 5, 3, -5, -3. See what I mean? All right, now, another concept that we're exploring in section 4.2 has to do with these glide reflections. And a glide reflection, I wish it was called a slide reflection because that makes more sense. A slide reflection, because look what they're doing. They're telling us to do a slide, then go and reflect. Do a slide, then go and reflect. So a glide reflection is what we call a composition of a translation and a reflection. A composition is when we put together more than one transformation. And so our glide reflections are going to be the composition of a translation and a reflection. The very first thing that I need to do is grab my pencil, and I'm going to put the triangle JKL into the grid. Now this is going by 2's. So J is going to sit at 3, 1. It's going to be floating. J is going to be floating at 3, 1. K, oh, I'm not going to put my letters on yet. Hold on. K is going to be at 4, 2. This is a little one. And then L's at 1, 3. It is small. So, you know what I'm going to do? I'm going to go out to the side and we're going to actually do the mathematics on the ordered pairs that go along with this so we can do one thing at a time. And I'm writing pretty small, which is strange for me. I'm going to go 3, 1, K, 4, 2, L, 1, 3. Now, next to these, I want to go do this slide. -6, move 6 left, down 1. Now, I want to write the points. This figure is really small. I'm really more interested in the points here. So take all of your x values and subtract 6. 3 minus 6 is going to give me a -3. All my x values minus 6. 4 minus 6 is going to give me a -2. 1 minus 6 is going to put that x at -5. I'm getting that from my translation, my slide rule right here. I'm getting that from my translation. Every x value has to have 6 subtracted from it. Every x value has 6 subtracted from it. Every y value needs to have, what is it? 1 subtracted from it. Let's write down all the y's that go with each of these. 1 minus 1, 0. 2 minus 1 is going to bring me to that. 3 minus 1 is going to bring me to 2. Now, this is my primes. This is J prime, K prime, L prime. Let's go put that on our grid. I'm not labeling the letters because I just feel like it's too messy. So I've got one color here, and now I'm going to go -3, 0, -2, -1. I'm sorry, that should have been +1. Nuts. And -5 and 2. So that figure just moved to right here. Dinky dinky. And ignore my little dot there because that was a mistake. So I'm not putting my letters on. I got all this stuff over here. This is too little. It's just too little. And then the last thing we have to do in this glide reflection is now we have to go and reflect over the y equals -x line. I'm just going to go and drop in my y equals -x line. So I slid, translated, glide. Now I need to take that figure, mine's in green marker, and I need to reflect it over this line. But we're going to go through how the xy changes and put those points. And this is exactly what we did in number 6. So when y equals -x, it's going to be the opposite of y, the opposite of x. We're going to switch and take opposites. Switch the xy's and take the opposites. So under this is going to be our J. We're going to actually call it double prime. J double prime, K double prime, L double prime. Thank God we don't have to write that on our grid. We have no room. If you've got a marker in your hand from the first transformation, the slide, change colors. I think it'll help. Now, switching my xy and taking the opposite. I'm at -3, 0. I got to switch them and take the opposite. The opposite of 0 is 0. The opposite of -3, though, is going to put me at +3. I'm going to actually drop that one on here. 0, +3. I'm putting that point on. I need to switch. 1, -2. Take opposite. -1, +2. There it sits, little guy. The last one, -5, +2. Switch them, -2, +5. When we started with that little dinky figure, I knew that going through these motions and getting the points on here was going to be more helpful. Now in number 8, we need to pick up our pencil and we need to draw that little dinky JKL again. We need to draw that JKL again. J, 3, 1, there it sits. K, 4, 2, there it sits. Little dinky guy. L, 1, 3, there it sits. Same little triangle we started with in number 7. And then we've got to perform our slide. Same triangle we started with in 7, and then we're going to perform our slide. Grab your a different color. Now my slide here is telling me that X stays the same. I'm going to try to perform this one in the plane. I'm going to try to perform this one in the plane. So this transformation is just telling me X stays the same, but I got to move the whole thing down 4. I think this is a little bit easier to do. I really do. If I'm going to pick this corner up and move down 4, this grid's going by 2s. 2, 4. There it goes. If I'm going to pick this little one and go down 4, 2, 4. There it goes. 2, 4. All I did with this first part of the composition was slide it or glide it down 4. I could have done all the ordered pairs. I feel like this one was a little bit easier. Now, what kind of a line is the X equals? Vertical or horizontal on that X equals? Look back. Got to be a vertical. If X is always 1, it's going to be a vertical line. I'm grabbing another color, and I'm drawing X equals 1 on my grid. Something pretty big that comes out of this. You guys note we're supposed to reflect over the line I just drew. We got points on both sides of the line. So what's going to happen is the points that are to the left of the line are going to go over and be on the right side, and the points that are on the right side of the line are going to go over and be on the left side. So if I'm picking this little one up, it's going to move over here. Picking this one up, it moves here. This one up, it moves here. Maybe kind of pick your colors so it stands out to you. But the stuff on the left went to the right. The 2 points on the right went to the left. Line of symmetry, lines of reflection. Kristen.
Your line's on X equals 2.
My line is on X equals 2. Nuts. Let's change it. Is yours on X equals 2? If you put it on X equals 1, yours was better than mine. If you didn't, nuts. Cross this off. I'm putting it on because I went to, yeah. It went by 2, yeah.
I was gonna say, why was it open so much? I put mine.
You put yours on X equals 1. If you put yours in the right spot, don't change the thing on your paper. If you followed my lead and went on X equals 2, let's just change the direction. Yeah, I can fix that. That's interesting that it took until I got done for somebody to point that out. Lines of symmetry, lines of reflection. Moving on to 9, 10, 11, and 12. These are actually going to be quite a bit quicker. Is there any reflection, or can I draw any reflection in the word moon? Mirror images? I don't think there isn't any. Now, wow, on the other hand, vertical or horizontal? Can we talk like that? I don't know if I agree with you. I think there's a vertical line of reflection. Yep.
It has to go through the word.
It does. Line of symmetry through the word. How about kid? Horizontal. The way that K is drawn, I could have mirror images if I went this way. Think about horizontal maybe for dock. Yeah. The way that line is drawn.
Yeah, how can you get it for dark and not moon?
Say it again?
Oh, never mind.
Because the end, yeah. All right.